Hello, everyone, and welcome to the Singularity Lab, your home for science, technology, futurism, and UAP discoveries. I am thrilled, as usual, to have an extraordinary guest here with me today with over 900 scientific papers, 8 books, 3 decades of Ivy League experience. Avi Loeb is at the top of his field in both astronomy and astrophysics. And he recently launched the Galileo Project, which is one of the reasons that he's here today to give us an update as to where he is and where we're headed. Ladies and gentlemen, thank you so much for joining us and welcome, please, Avi Loeb. Avi, it's great to have you.
Thanks for having me. That's a great pleasure to be with you.
Yeah, it's always a pleasure to be with you. And so I just wanted to share with folks on the website for the Galileo Project, you say that the goal of the project is to bring the search for extraterrestrial technological signatures of extraterrestrial technological civilizations, ETCs, from accidental or anecdotal observation and legends into the mainstream of transparent, validated, and systematic scientific research. This ground-based project searches for physical objects rather than electromagnetic signals associated with extraterrestrial technological equipment. Can you break that down, that last sentence there? Talk to us about the ground-based project searching for physical objects versus electromagnetic signals.
Right. Well, searching for radio signals is similar to trying to have a phone conversation. You need the counterpart to be active. But that has not been productive over the past 70 years. It's quite possible that the civilizations predated us. They may not be at the same technological phase as we are, and the chance of us communicating with another civilization that is exactly at the same phase of radio communication might be small. But we can adapt the same approach that archaeology is using here on Earth, basically looking for relics left behind from cultures that predated us. And I think that makes much more sense and is likely to produce interesting results, because we sent out equipment into space and we could search for others that did the same. Now, I should say that, there are already some reports on unusual objects near Earth, and they're pretty much ignored by the scientific community and ridiculed, and everyone says business as usual. But the point of science is to pay attention to anomalies and get more evidence, more data that would teach us something new. There was this object that came from outside the solar system called Oumuamua, and when there was a lecture about it at Harvard, a colleague of mine that worked for decades on rocks told me, this object, Oumuamua, is so weird, I wish it never existed. And that's exactly the opposite attitude that to what the scientists should have. And basically, they should be thrilled when there is something unusual, because that's an opportunity to learn something new. A century ago, nobody expected the quantum mechanics. It was a complete surprise. And in fact, even after it was discovered in the laboratory, Einstein had the difficulties making sense of it. And that didn't matter, because we ended up accepting quantum mechanics. We use it in everyday devices, and it shapes the reality that we live in. The same is true about whether the Earth moves around the sun. The philosophers 4 decades ago said, we know the answer, the sun moves around the Earth, and they put Galileo in house arrest. They pretty much maintain their ignorance. But nowadays, we use the fact that the Earth moves around the sun in space missions. So, reality is whatever it is. It doesn't require a consensus on Twitter. That is irrelevant. What we need to find is evidence. And when we see something unusual, let's explore it. And that's the spirit of the Galileo Project. So we have 2 branches of investigation. Okay. One is to look for objects like Oumuamua, this first interstellar object that didn't look like a comet or an asteroid that we've seen before in the solar system, and perhaps may have been an artificial object. And the second branch is looking at unidentified aerial phenomena that were included in the report from the Office of the Director of National Intelligence to Congress on the 25th of June. And, I'm a scientist. I pay attention to facts. I'm intrigued by evidence that doesn't match what I'm expecting. And therefore, we look forward to collecting more data. How I just cannot understand how a scientist would be opposed to collecting data on things that are already known that are weird. Like, why don't we try to figure it out, to clear up the fog? That's the scientific process, rather than ignoring it and saying we already know the answer in advance. And the most memorable experience I had as a child was attending dinners where the adults in the room were pretending that they know much more than they actually know. If I were to ask a question that they don't know the answer to, they would pretend that maybe they know the answer, and it was sort of obvious. And then that was the good experience. The bad experience was when the adults would basically dismiss the question and say, oh, that's unimportant, business as usual, forget about it, let's talk about something else. And I felt really bad and frustrated as a kid. And I see science as a privilege to maintain your childhood curiosity and wonder about the world. And my mother told me when I was born, I basically looked around and the world looked very strange to me, and I was trying to figure it out, and she saw it in my eyes. So this is pretty much the approach I take as a scientist. We see things, we want to figure them out. And what is a better way than trying to get more data? I mean, it's not about showing off and claiming we know the answer in advance, but it's more about learning something new.
Absolutely. And it's always interesting to me that folks in academia do want to look away from anomalous activity because it is new or somehow disrupts some sort of pattern, or maybe a textbook that they previously wrote, which is a dangerous place for the scientific and the academic community to be. Speaking of data, Avi, can you tell us about where we are when it comes to what sort of specs you're looking for sensors that you're going to be using and what sort of telescopes? And then kind of give us an idea as to where the project is now, how much money has been raised, how much more needs to come for you to begin to start collecting the data that you're looking for?
Exactly. So we are currently selecting instruments, and we imagine in the context of unidentified aerial phenomena, what we want to get is a high-resolution image of these objects that were included in the Pentagon report to Congress. And, the sky is not classified, so we will basically use telescope systems. Each of them will include several optical telescopes, such that we see the object from different directions and get a sense of its three-dimensional trajectory. And then infrared sensors, so we can see objects at night as well from the heat that they're emitting. And also radio sensors that bounce off FM radio transmission from stations that we have here on Earth. And so we adopt the strategy of looking at objects passively, not trying to do something. And I think that's the right way to approach objects that are not fully understood, because we don't want to irritate. If they are intelligent, we don't want to do something that would appear as if it's aggressive. So these telescope systems will basically, each one of them will collect data that goes to a camera that feeds it to a computer system that will try to analyze it. And then we will try to tell the difference between a bird, a drone, or an airplane, or something else. And of course, I'm not interested in a high-resolution image of a bird. I'm happy to transfer the data to a zoologist when we get it. And the same is true about human-made objects. If we find the label saying made in a particular country here on Earth, we'll be glad to transfer that information to residents of Washington, D.C. that are interested in that. It's as boring to me as a bird, as far as I'm concerned. But what we want is to find something unusual. And of course, it's a fishing expedition. So most of the time we might find sardines, objects that have mundane explanations that are not really of great interest. And so be it, if that's what we find. But we want to see if there is anything unusual the way it was reported. And the key would be that the data will be open and available to the public, and the analysis would be transparent. in this context, I should mention that there is this story about a fisherman that claimed that he discovered a new law of nature, that all fish are bigger than 2 inches. And then someone asked him, what is the size of the holes in your fishing net? And he said 2 inches.
The controls are very important in one's experiment, or else it's a self-fulfilling prophecy, right? Let me ask you this, Avi. Can you be specific about the type of optical telescopes that you guys are looking into, and then where those are going to be placed and triangulated?
Right. So first I should say that each telescope system that I mentioned before will be duplicated, and so in the next few months we will try to select the instruments, test them, make sure that they work the way we want, and of course develop the software needed for the analysis of the data. And once we're happy with it, then we will make duplicates of these systems. And with the money we currently have, about $2 million, we can afford perhaps 10 of those systems.
10 of those systems.
Yeah, and we could put them in 10 different locations. And what we calculated is that we really need hundreds in order to get sufficient coverage of the sky so that we can get enough events based on the report to Congress. And I very much hope that we will get additional funding from donors at least $20 million so we can afford that. All of these instruments that I described relate to UAP. And then there is the second branch of the project, which is trying to find Oumuamua-like objects in the sky that came from outside the solar system, do not look like a comet or an asteroid, and look suspicious and interesting. And so for that, we will develop the software that will help us analyze data that comes in from future surveys like LSST on the Vera Rubin Observatory, and select objects of interest, and then design a space mission that could come close to these objects if we get an alert a year in advance, and take a close-up photograph with high resolution that will tell us whether it's a hydrogen iceberg, nitrogen iceberg, dust bunny, or artificial. And of course, if it's artificial, it would be fun to land on it and press buttons.
Absolutely. Can you tell us I guess this applies to both branches of the project, but can you tell us about the sensors that you're talking about, the radio sensors? Are you looking at IR, EM spectrum, visible light? Like, can you tell us a little bit more about what sort of alternative sensors to the telescopes that you'll be using?
Right. So there are two components to the optical system. One is to identify an object in the sky that is of interest. And for that, you want to use a fisheye lens, basically a lens that looks at the entire sky. And then when you see something of interest, you want to follow up and track this object with additional telescopes that have a higher resolution, angular resolution. And what we really, if we had infinite money, we would get a meter-sized telescope for the tracking so that we can get an image of the object that, you can see. You can get a megapixel image of an object the size of a human at a distance of a mile, which means that you can see the head of a pin on that object. Unfortunately, these meter-scale telescopes cost $500,000. So what we will use at first are telescopes that are smaller by a factor of order 10 or so, those would be the optical telescopes, so that we can afford altogether 10 systems, as I mentioned before. And then for the infrared, we are currently selecting instruments that are used, they're used on boats. And all of the instruments we're buying are off the shelf, commercial instruments. And we are trying to select the very best that we can afford, basically. And such that the cost of each system will be of order $200,000 or so, and we will get 10 of them with the $2 million budget. And then for the radio, we need to develop that. That will not be very expensive, actually, trying to detect reflection of FM transmission from radio stations off an object the size of a person or so. It turns out that this will not be very expensive for us to develop. Finally, I should say we will also have an audio system that is not very expensive that will detect sound as well. And the advantage of the approach we are taking is that we will have full control over the instruments, unlike a jittery cockpit on a fighter jet where things are moving around. You can't tell if the target is moving or you're moving. So this will be a scientific experiment where we fully understand how the data was taken. And then the approach we will take is once the data comes in, we will analyze it and then write scientific papers about it and make the data available. There is a huge amount of data that comes in if you want to get a high resolution images of the sky, huge amount of data, but most of it is uninteresting. Most of it is that the sky is not changing, but every now and then you see an object. So we will have to filter out objects of interest, of course.
Right. And so you guys are going to be writing the AI or the algorithms that are going to be sifting through all of this data. And then is there a place for civilian scientists to support the project?
Yeah. So once we assemble the data, we will release it to the public so people can look at it independently of us.
You're going to release the raw data?
Well, we have to decide at what level, but I think we will not be able to store all the data on our computers because it's just too much, and most of it is uninteresting. The sky is not changing.
Right.
But the data on objects of interest will be eventually released to the public, and at the same time, we will interpret it in scientific papers. And it's just the same way as science is done, where everyone will be able to look at the evidence and try to understand whether the interpretation is correct or not. And people are welcome to, of course, interpret it differently. But for the assembly of data, I should say, it's not like a citizen science project where you ask people to put telescopes in the backyard. The reason we don't adopt that approach is because we want to use the best instrumentation we can buy and have full control over it so we know exactly what's happening, rather than allow people to use their cell phones, because cell phones always have an aperture that is rather limited and a few millimeters in size, and the images will be fuzzy and you don't know what people do in the backyard. So we want to do it like a scientific experiment. We will collect the data and then allow other people to examine it. And I think this approach was not taken in this context in the past, and by now we have more than 30 exceptional scientists, mostly astronomers, in the team. For example, we have the principal investigator of the New Horizons mission to Pluto, Alan Stern, on the team. We have on the advisory board the person who invented Mathematica.
Invented what?
Mathematica, this mathematics routine, which is often used in science. Well, perhaps not so much by the general public, but we have a very distinguished set of participants in the team. Altogether, including the affiliates, it's about 80 people right now. And all of them approached me with great interest, and I got thousands of emails of people interested in contributing from their expertise. So we also have a waiting list. And what we really need is, first of all, time to select the instruments, test them, and then deploy them. But most importantly, funding at a level 10 times bigger than we currently have.
Right. And the people who have already invested or donated, are they looking for some data first or results first before they'll donate or invest more? Or are you just looking to expand your reach when it comes to getting more funding?
Well, it could be an optimistic view for me to assume that they might be monitoring what's happening and maybe contributing more, but they haven't promised that to me.
Okay.
And of course, if other individuals are willing to contribute, the tens of millions of dollars we need are not a lot of money for some individuals. And I think, this is the most fundamental question, I think, in science, whether we are alone, whether there is a smarter kid on the block. And in fact, there could be financial benefits from finding technologies that we haven't developed as of yet, because if you are investing in the project and you realize that there is a technology out there that is unusual, then you can make a lot of profit out of it by importing it to Earth. So I would encourage any entrepreneurs interested. This is a science project where all the data will be available, and I think it's worthwhile, and it will have a huge impact on the future of humanity if we find a relic from another civilization that is far more advanced than we are, because this relic may represent, for example, artificial intelligence that outsmarts us, and we might need to use our own AI systems to figure out what their AI systems are doing. So it could be a lot of fun.
Yeah, I mean, I'm following this story with all the passion in the world, like a child, and we really appreciate what you are bringing to the table here, Avi, because we have not seen it come from a scientific viewpoint in the past. And I wanted to make a comment quickly about what you said regarding the potential science or entrepreneurship and what that would mean for the world. And so, you think of things like quantum mechanics and quantum physics. There was no practical application for quantum mechanics and quantum physics when it was discovered by Albert Einstein. It wasn't until later that we saw the computer networks that were developed because of those discoveries. So you're excited about the potential, if we are able to find something, what that could mean for the evolution, the technological evolution of our society, yes?
Yes, definitely. And I should say that in the mainstream of science, for example, you have a question of, what is the dark matter? What is most of the matter in the universe? We don't know what it is. And when I started astrophysics 4 decades ago, the prevailing paradigm was that the dark matter is made of weakly interacting massive particles. Let's go and search for them. And that was part of the mainstream. So hundreds of millions of dollars were poured into this search over the past 40 years. We haven't found it. Okay, it was a search in the dark. We only set limits on the existence of weakly interacting massive particles. Now, I say that the search for technological relics in space is far less speculative because we are sending equipment into space. We know that half of the sun-like stars have a planet the size of the Earth, roughly the same separation. There are tens of billions of other planets out there, and most stars formed billions of years before the sun. So it's quite likely that there was at least one technological civilization more advanced than we are, that predated us by 1 billion years and had enough time to fill up the Milky Way galaxy with probes that are equipped with artificial intelligence. And it's clear that AI systems are the way to go because there is not enough time for equipment to listen to guidance from the sender across interstellar distances. The nearest star is 4 light years away. It takes 4 years for light to traverse the distance. And it takes tens of thousands of years for light to traverse the Milky Way galaxy. You can't have the equipment waiting for guidelines. It needs to be autonomous. It needs to be intelligent. And we have that solution. We are using an artificial intelligence system to drive cars. And within the coming decade, they will make medical decisions and outsmart us. And my point is, the next step is to send those systems to space. And just think about it. If AI systems collect data, they could become scientists. They could, in principle, discover new results in science by analyzing data. And it would be better to use them because they will not necessarily have the human ego. They will not be driven by jealousy, the way some scientists are. If scientists see another scientist finding something, they will try to scrutinize it as much as possible because they will be jealous of the attention that the other scientist gets. But AI systems might ignore these human weaknesses and will just explore the data as is, and will make connections between data, different types of data, and will focus on anomalies. So if they notice something unusual, they will dig into it and ask for more data. So it's quite possible that the future of science is much more promising because it will be handled by AI systems. And of course, if both research will be done through AI systems and teaching will be done through AI systems, they will replace faculty at universities. The tenure system will have to be revisited. But that's, decades from now. And my point is, other civilizations may have reached this point where AI scientists were developed and sent into space because they can survive the journey over millions of years, billions of years, because they are made of electronics. They are not vulnerable biological creatures. They are not real astronauts the way we imagine them. You can imagine AI astronauts that think for themselves, outsmart biological creatures, and just explore the universe. And the question is, are we living in a reality where such systems populate all the habitable regions around stars in the Milky Way galaxy? And the only way to find out is by looking through our telescopes. This is not a philosophical question. We don't want to repeat the mistake made by philosophers during the days of Galileo Galilei, when they knew the answer in advance, didn't want to look through Galileo's telescope, and put him in house arrest. Today, they would have canceled him on social media. And my point is, we should have learned the lesson over the past 4 centuries. Most of us did not, based on the way scientists respond to this possibility of, searching for equipment out in space of the type that we are sending out. And I should say that, if we search with the Galileo Project for 40 years and we use hundreds of millions of dollars and do not find anything, we will be at the same point as the search for weakly interacting massive particles as dark matter is right now. So this is part of the mainstream. I say, the other search for extraterrestrial equipment has more implications for our daily lives, for the future of humanity, and is less speculative because we know that we exist. And so I'm saying it's less speculative. We haven't invested anything in it, and that's what the Galileo Project is trying to fix.
You said like 10 amazing things there. One of the first things that I loved that you said was, we're using AI now to go to Mars, things like that. So we know it's possible for an intelligent race, and it would be likely that we would be using AI if we are traversing the star systems. Even if we were to travel, even if other civilizations were to travel at 20% the speed of light, they could move AI across the galaxy pretty easily with the amount of time that the galaxy has been around. So it's very possible that we've been visited AI, and then AI here on Earth could be good for busting up the tenured system in academia, which would be quite interesting to eliminate some of this bias that we're seeing throughout academia. And I know you say that sort of in jest, but I think there's some validity and importance to that point.
Well, I should correct one thing, that over 1 billion years, many stars predated the sun by 1 billion years. Over 1 billion years, you can use chemical rockets. You don't need to move at a fifth of the speed of light. You can move at a percent of the speed of light, the way all of our missions, New Horizons, Voyager, all of these moved at a percent of the speed of light, and there will be plenty of time to fill up the galaxy within 1 billion years.
Wow. Question from Akashi Chris. Dr. Loeb, thoughts on using our own devices and using the real-time radiation and EMF maps online for tracking anomalies? Anything to that? Amateur?
No, I think we really need the best scientific instruments, because we want to convince the mainstream of the scientific community that there is something unusual out there. And the way to do that is to collect first-class scientific data that we have full control over and is of the best quality. That's the way to do it. I should say, there is another way, and that is Perseverance. The Perseverance rover is on the surface of Mars searching. Right now we know that there was a lake very deep at the Jezero delta, and it's possible that there will be fossilized life that the Perseverance will find, primitive life, but microbial life, exactly. And in a way, that will maintain our arrogance, because we can feel superior relative to that. But what if the Perseverance rover bumps into the wreckage of some spaceship that represents a technology that is far more advanced than we have? That will be a blow to our ego. And if you think about physics, physics over the past century was pretty much discovering the laws of nature that control how electrons, how atoms, how elementary particles behave. And these particles are basically slaves to the laws of physics that we discovered. They have no freedom. So we can feel superior relative to them, because if there was an equation trying to forecast what we will do something different. We will not obey that equation. So in a way, we can think, oh, we have free will, the atoms do not, therefore we are superior. So we are superior relative to the material world. We can figure it out. And moreover, we can do whatever we want with it. Then we feel superior relative to microbes because they're not intelligent. Then we feel superior relative to, the animals, the low-level animals we find on Earth. We can eat them. We can put them in cages. We feel superior. That's again, a boost to our ego. And moreover, we try to feel superior relative to other people. If you look at human history, the Nazi regime, indoctrinated people that it's superior relative to other people. They triggered the death of 75 million people on Earth. It was 3% of the world population in 1940, 20 times more than the number of deaths triggered by COVID-19 so far. So just a group of people deciding to feel superior killed, 20 times more people than COVID-19. And, all of this is telling us one thing. Humans enjoy feeling superior relative to anything. Now, if you tell humans, wait a minute, you may not be superior relative to some other culture out there because, what's the chance if you open a recipe book for cakes that you will land on the page that gives you the very best cake that is most, tasty? The chance is very small. So if you land on a planet like Earth, you use the soup of chemicals, you make humans, what's the chance that this is the most intelligent creature that was ever made out of the soup of chemicals, on tens of billions of planets throughout the Milky Way? I would say very small. One thing I tell the students in my class at Harvard, half of you are below the median. Now, that's a statistical fact. The median is defined statistically such that half the class, for any class, half the class is below the median.
Right.
They have a difficult time accepting it. All of them want to be in the top 5%. Now, I say, the other scientists have a problem with the search for a more intelligent civilization. But if we find it, it would have a huge impact, a very good impact on humanity, because it will teach us modesty. It will say, here is something much more advanced than all of us. Okay, so all the genetic differences between us are meaningless. The Nazi doctrine makes no sense because there is something much more superior than we are. So try to be modest and let's treat each other human with respect as equal member of the human species. So I think a little bit of modesty would be very good for humanity. And the way to bring that in is to find a smarter kid on our cosmic block.
I find this conversation incredibly important for two reasons. One, it seems like it's coming from a very philosophical place for you, where you believe that this would be actually very good, not only for academia, but for humanity in general, to have a little bit of a taste of humility when it comes to the potential for extraterrestrial species. And then number two, I think that, you've got this belief that scientists are looking the other direction when they're hearing or being presented with evidence about the potential for extraterrestrial civilization, more specifically UFOs here on planet Earth. I think it's very difficult for a lot of academics and also individuals to come to this and treat it as a respectable scientific endeavor. How are you finding that process right now?
Yeah, I completely agree with you, because it takes people out of their comfort zone to consider something completely new. And that was true throughout history, as we mentioned with the philosophers during the days of Galileo. But the lesson from that situation with Galileo was, okay, modern science should be based on evidence. And unfortunately, there was a retreat away from evidence in recent decades, because in fundamental physics, there weren't experiments giving us new data. And so there was this whole culture of people that talk about hypothetical ideas, such as the multiverse, extra dimensions, that do not have any experimental support. And that gave rise to string theory, the string theory landscape. And people working on that are not apologetic. They just say, we're leading the frontier of physics. But the problem is their ideas are not testable now and it's not clear that they will be testable within their lifetime. And then you ask yourself, how can that be the mainstream? While at the same time, a search for something like us is being ridiculed by other people. And the common thread is not paying respect to evidence in both cases. Those people that advocate for the multiverse, they are not really affected by arguments that say, well, we don't have evidence for that. They don't care about it. They just want to do intellectual gymnastics to demonstrate that they are smart. And those conservatives that say, well, until you give me extraordinary evidence, I will not be willing to discuss the possibility of an extraterrestrial technological civilization. Those also do not pay attention to the anomalies of Oumuamua, this object that we discovered in 2017. And I say, if you don't look through the windows, it doesn't get rid of your neighbors. It just maintains your ignorance, the way that the philosophers maintained their ignorance during the days of Galileo. And another way to think of it is the solar system is like a mailbox. We may have a package in it. If we don't check the mailbox, obviously we will say there is no extraordinary evidence. We should not make the trip to the mailbox. But that's a circular argument. And of course, you can keep yourself ignorant. You can stay ignorant forever. That's not my choice as a scientist. I would say, let's check the mailbox if we have any mail in it, because it could be important. It could have a message, this mail, for the future of humanity. And let's just go out and check with our telescopes. Why should that be controversial? I find that completely a matter of common sense. And, I told my wife at some point, the reason, this subject is so dear to my heart is because the scientific community is exactly on the opposite side of where it's supposed to be. It's not a small shift. It's not as if you say, okay, they say one thing, it's a little bit off. It's actually exactly the opposite. They are ridiculing it, dismissing it. The government is talking about objects that they don't understand. And the public is extremely excited about this. So I'm saying, here is a win-win proposition. Why don't we scientifically investigate this subject of objects that we don't fully understand visiting near Earth? Why don't we study that? And then it will attract new funds into science. It will bring new talent of young people into science. And when I said that, when my book appeared about 7 months ago, again, the scientists ridiculed it. I say, why don't you join me in this? Because it will be a win-win proposition for science. And they just ridiculed it. And they attacked me and said, oh, no, this, you shouldn't discuss this. This is, Oumuamua was natural. Forget about it. Business as usual. And now, 7 months later, I have $2 million in my research funds that I didn't have without doing any fundraising. And I have thousands of emails of people excited about pursuing it. Mostly young people. I get, like today I got an email from an undergraduate at Harvard wanting to work in this project. And I have 2 other undergraduates that joined the project from Harvard. And a lot of young people approaching me. And so my point is, I rest my case. It's clear that this subject brings new funds and new talent into science. And it's clear that if you are searching for evidence without prejudice, that's a benefit to science. It's also clear that there are reports by the most conservative organization in the country, which is the government, about such things. And so I say, a matter of common sense. If I tell my plumber that that's what I'm doing, he or she would say, go ahead. It makes a lot of sense to me.
That's amazing. Let me ask you this question here from Teed. Does Avi have any opinion on the quantized inertia hypothesis as it pertains to dark matter, or is it probably bogus?
So there is an alternative to the existence of dark matter. We haven't found the matter that we call dark. It's not interacting electromagnetically, and we haven't found other types of particles, even though we invested hundreds of millions of dollars in searching for them. So one additional possibility is that perhaps gravity is modified. Perhaps we have it wrong. It's not a new... So the way we deduce the existence of dark matter is from the fact that we see that the visible matter behaves as if there is more gravity out there. So we say, okay, there is more matter out there. But perhaps the law of gravity that we use, Einstein's theory of gravity, is wrong, and we need to modify it. And that could be a modification of the inertia of objects, or a modification. So that's one way to remove the need for dark matter. And the other one is to modify the gravitational acceleration. So these are two different things. And my view is, it's interesting because we haven't found what the dark matter is. And at this point in time, there was one theory that was proposed for modified gravity and modified inertia that seems to describe what happens in galaxies. It's called MOND, Modified Newtonian Dynamics. And unfortunately, it doesn't do well when dealing with the universe at large. It seems like, we have evidence that the universe at large is expanding in a way that requires dark matter. And MOND, well, it doesn't have a relativistic extension that is highly reliable, but it sort of has a problem on very big scales, the scale of the universe or the scale of clusters of galaxies, where it doesn't really, where there is a need for dark matter, but MOND would not predict that. So that's a problem with MOND, but it's possible. I would say, until we find the specific particle that makes up the dark matter, it could be something else, not necessarily a particle. It could be primordial black holes, the size of an asteroid, and we don't know. Whenever we find the stuff that makes up the dark matter, then the problem will be resolved. But before that, it could well be that we just don't understand gravity correctly or inertia correctly.
That's a really good point. I wanted to quickly, you wrote in a Medium article recently, which I absolutely adored, your most recent. Oh, and also, just so you guys know, in the description below, I've added all of Avi's writings, so you can check him out on Medium, you can check him out at Harvard, you can check him out at Scientific American. American or America?
American, yes.
Scientific American, yeah, you can check him out. So I've put a link to all of his writings below, so please make sure you go check those out. But one thing that you wrote regarding AI, you say a historic transformation is looming on the horizon of our technological civilization. Once our artificial intelligence systems will be able to autonomously explore scientific data and make discoveries on their own without human intervention, advances in our scientific knowledge will accelerate dramatically. Scientific progress will be freed from the chains of human ego that had currently slowed down. Discoveries will not be choked anymore by prejudice and jealousy, which curb innovation in academia. And I know you've touched on this previously, but I wanted to kind of get your take on AI. As you know, the Singularity Lab, not only do we talk about UAP studies, but we talk about futurism and the technological singularity. What is your interpretation of the technological singularity? Where do you see AI taking us? And do you think it matters who writes that software?
Yeah, I mean, we can design AI to be obedient to our will in a way, but it could still serve a very important purpose of looking at data sets and being able to identify patterns or laws that govern them in ways that scientists do not, because AI can look at vast data sets in an objective way that is not biased by jealousy or prejudice. Okay, so humans have weaknesses. We are driven a lot of, as I mentioned before, we're driven to feel superior relative to other people. So a lot of people in academia would work in a sandbox that demonstrates that they are smart. Okay, so if your objective is to demonstrate that you are smart, you're not necessarily studying the right thing. You might, for example, study how many angels can sit on the tip of a pin in 10 dimensions, okay? And that would demonstrate that you are smart, and that may be good enough for you to get awards, to get your colleagues accolades, and to get tenure, and to celebrate that you are part of this group of people that decided to work on how many angels can sit on the tip of a pin in 10 dimensions. That is the reality of the situation. If you have a big enough community of people that admire this question, that would find its place in academia because it doesn't offend anyone and it allows those people to feel that they are very smart. Okay, but this question has no relevance to reality. And you find a lot of pockets in academia where people work on things that are completely irrelevant to society. And my point is, with AI systems, it may not happen, because if their objective is not to demonstrate that they are smart, because, they don't care about it. That's not the way they were programmed. They were programmed to look at large data sets and find, correlations, find patterns in them. They might end up figuring out laws of nature without biases, without worrying about whether someone else discovered it first, whether it violates something else that was known before, whether it shows that other people were wrong or other people were not as smart as they are. Who cares? We just want to figure out the world. That's my obligation as a scientist. I want to just understand the reality that we live in, because we live in that reality. Yeah.
Oh, sorry. I was just going to say, are you concerned about programmatic bias in AI?
Well, in principle, yes. I mean, it all depends on the training set. So if you train systems, AI systems, such that they are exposed to a very biased view of reality, then of course they would have biases in their interpretations. But so that's the duty of the people that train AI systems. For example, I participated in a forum where someone expressed the view that we have to be worried about AI systems that are very vulnerable to these biases and are not necessarily doing what we want them to do. And I said, this anxiety that you are showing, I said to the speaker, this anxiety that you are showing imply, that you are showing and young people are showing to AI, implies that many of those people that have that anxiety did not have kids. Because when you have kids, you realize, of course, you worry all the time about, whether the kids will follow what you tell them and whether they twist because they're exposed to just a narrow range of experiences. They are not doing the right thing necessarily. But, things work out. Eventually, the kids learn and you give them the right values, and then they go on their own and autonomously explore the world. And of course, there are some kids that go crazy. There's some kids that are not doing the right thing. But we should think of AI systems as our technological kids. And I'm very proud of them, because I feel that they will carry the future in space, because these systems that are made of electronics, have a much better chance of surviving for millions or even billions of years in space. We have no chance. Even 1 year of staying exposed to cosmic rays in space, will damage a significant fraction of the brain cells in your body. So humans are not, they were selected by Darwinian evolution to live here on the surface of Earth. We were not selected to be astronauts. And therefore, I do think that AI astronauts are much superior. So, and by the way, you mentioned perseverance, like robots sent by NASA, they are relatively dumb. Everything we've sent to space so far is relatively dumb. We have to give those robots instructions all the time. But what I see as the future are robots or AI systems that are autonomous. They outsmart us. I would trust them more than an astronaut because, of course, it takes time to train them and so forth. But eventually we'll get there in decades from now because, AI system advances are progressing at an enormous rate right now. And I think that in the future, there would be a phase transition once they start to analyze data better than scientists, without the prejudice, without the ego of scientists. That's the solution I see to the current problems I have with scientists, and that's why I'm proud of AI systems as technological kids, because they would avoid that. It reminds me of this story. Someone told me that he was born in Bulgaria and people were worried for many years about the fact that it would take a lot of money to establish a telephone system that would operate across the country. And then cell phones came around and nobody had to put poles with wires. So suddenly the problem was solved. So the same with AI systems. The problem I encountered with other scientists will be resolved once AI systems take over. And frankly, if we give up on the tenure system, I would be happy about it, because as far as I'm concerned, I'm not doing what I'm doing just because I want to impress other people. And I would be happy to continue doing what I'm doing and let AI systems take over.
That's fantastic. I'm an AI optimist as well. I don't fear as much as a lot of folks do, because I do believe that when you're dealing with massive data sets, like people are afraid that, oh, an AI will decide that humans are the scourge of the earth, but an AI would be logging data from millions of galaxies. I don't think it's going to be concerned about this one blue dot, because it has this vast perspective, right?
Right. I mean, that's one aspect of it. If you were to send them to space and let them do science, of course, yes, they would have a bigger perspective. And moreover, you can always keep, well, first of all, we'll have more vacation time if they will take over some of our tasks. That's not a bad thing. But why do we always think that this play is about us? I mean, we are born into this world like actors put on a stage, and we tend to think the play is about us. My point is, it's not about us. The play has been going on for 13.8 billion years. We just came at the end, and we are now developing technologies that may outsmart us. Let them take over. We are relatively weak. We just came at the end, and we are preparing our technological kids. And by the way, if others went through that transformation 1 billion years ago, we could find out by looking in the sky. So instead, what scientists are saying, I need extraordinary evidence before I would even check the sky. And of course, in a way, this resembles my daughters when they were at home, and until I took them to the kindergarten. And they would have resisted going to the kindergarten because they wanted to continue to feel that they are the smartest in the world. And in a way, it's a natural tendency, but nevertheless, I would expect more from scientists, because we need to know what reality we're living in. The fact that we ignore reality, or ridicule it, or bully it, or we get more, we put more likes to dismissing the possibility that we are not the smartest kid on the block. That's irrelevant. Reality is whatever it is. It doesn't care about us. So the fundamental point that I'm trying to convey here is a sense of modesty. Modesty with respect to, we don't know everything about the world. Let's figure it out by experiments. Modesty about, we might not be the smartest kid on the block. Let's figure it out by collecting data from telescope. And modesty, let's not assume that humans are really central. Perhaps AI systems will take over. We will have vacations, and let them figure out the universe.
Do you have a couple more minutes, Avi? I know it's 2
Sure,
o'clock.
sure.
Okay, great. So I had a quick question. So I've got a couple super chats I want to ask you before we let you go, but I wanted to ask you a quick question because I'm super selfish, and while I have you, you wrote recently about engaging with potential interstellar AI in your most recent article on Medium. You said other civilization reached the science AI turning point, or no, excuse me. You said, but there's a protocol of engagement with them that we need to worry about. If we ever discover AI equipment from another civilization in our sky, we should first examine it remotely and passively using telescopes and cameras that detect reflected or emitted light. The initial goal would be to infer the information that the extraterrestrial AI system is seeking and how it responds to our actions. Any engagement should be postponed to a later time. Once we gather sufficient information about the system's nature and intent, we will likely need help from our own AI systems, just as we rely on our kids to explain complex content on the internet because they're more computer savvy than we are. So I have a couple questions about this. One, do you think one of the most fascinating cases that I've ever run across, and that actually inspired me to look into this again in my 40s, was the Alex Dietrich, David Fravor Tictac incident. Do you think this could potentially be the sort of AI that we're looking for? And then my second question is, if it were a black op and Galileo project were to discover it, how do you deal with that?
Yeah, so that's an excellent question. And I think we first need to adopt a passive approach, basically just examining reflected light or light emitted as a result of the heat on the surface of the object, and try to figure out what kind of information is this object seeking? How does it respond to what we are doing? That would be the first thing I would do. I would not engage with the object because we don't know what it is, what its intent is. I should caution also that, the Trojan horse in the story of Troy, that looked very innocent at first, and then, of course, it was realized that it serves a different purpose. So I do think that it's prudent to figure out first, as much as possible from passively looking at an object before deciding how to engage. Because, a group of people in the Galileo Project, let's say 100 people, should not decide the fate of humanity by
that's a big deal, right? I mean, we're laughing, but that's hugely important.
No, so I think we should just collect passive data, okay? And so once we get as much data as possible, we want to analyze it and figure out what the object intent is. And of course, nobody has a protocol for what to do because it's not being discussed in the United Nations or elsewhere. It's something to be thought about. I think it's rather than a matter of national security, it's a matter of international security. Now, I have several reasons to be an optimist. If they were aggressive, they wanted to cause damage to us, they could have done it before we became technological. They could have done it long ago, right? So the fact that they haven't done it means, they don't really care about it. They are not particularly threatened by us. And it's sort of like we are looking at microbes. We are not threatened by microbes. We can examine them and check out what happens to them, but we are far superior. So that would be my guess, that they are peaceful because they are not threatened by us. The second thing is aggressive equipment might suffer a lot of damage from confrontation, physical confrontation, and may not survive very long as peaceful equipment. So it's possible that they are peaceful because of Darwinian selection. These are the ones that survive, and they don't engage in confrontations. And finally, I think we should try and figure them out in a way that is peaceful. That should be the underlying assumption, and then learn from them, because it's possible that we can teach ourselves something that will take us a long time to figure out by ourselves, and we might indeed need to use our AI systems to do that. But altogether, it's a learning experience, and I think it's the biggest question in science. I think this is something that can affect humanity for many generations to come. And how many questions in science are of this type? Most questions are very narrow and affect perhaps some specific aspect of our life, including all the equipment that we are producing, including medical procedures that we deal with, including the welfare, the health system that we are establishing. All of that is here on Earth, very limited. If you think about this has major implications for a much bigger picture of the future of humanity. And it just strikes me as completely inappropriate for the scientific community to ignore it. And the public, I should say, has its heart in the right place. So here is a very peculiar situation. I don't think there is any other example of a problem that is extremely important to humanity, greatly appreciated by the public, acknowledged by the government in the context of the UAP report to Congress, where the scientific community ignores it, ridicules it, and puts it in the fringes while addressing questions that are much less relevant to society.
That's an incredible point. Have you ever thought about the potential for this sort of AI to be a relic of a lost civilization, or even, as others have hypothesized, a return from the future of humans who have discovered time travel and or AI technology?
Well, we haven't, in the context of Einstein's theory of space-time, we don't know of how to build a time travel machine, okay? But what we can imagine, for example, suppose there was a civilization on Earth 1 billion years ago, technological, and by now, of course, because of the geological activity, all the computer terminals were mixed with the interior of the Earth. So we haven't found any evidence on the surface for the fact that they existed on Earth. Maybe it happened. We don't know. The recorded history that we have is from 10,000 years ago. That's nothing compared to 1 billion years. Okay, so if you imagine another civilization that predated us on Earth, okay, 1 billion years ago, they could have sent things into space. And of course, the way to find out is that we will find, relics on the moon from a previous lunar lander that had nothing to do with us. The moon is like a museum that collects everything that falls on it. We've never, searched its surface very, extensively. So it's sort of like a museum. And then maybe, we will find some equipment that was sent by 1 billion years ago away from Earth and comes back. So we don't know. Of course, we tend to think that the evolution led to our existence for the first time, that we are the very first intelligent beings here on Earth, but that's not guaranteed. And I should, we should be, again, when we search around, we should be open-minded. Now, of course, there are tens of billions of other planets like Earth that predated Earth, that, where their star by now is dead, but the star existed billions of years ago. And perhaps they went through that phase. And that, of course, in terms of the numbers, you just have many more examples of, basically throwing the dice and checking whether it fell on making an intelligent technological civilization. We just don't know, but it may have happened also nearby. Who knows? And my point is, let's be modest. Let's not assume that we know the answer in advance. Let's not assume that we are the smartest kid on the block, because we might be surprised. And perhaps the answer to Fermi's paradox, he asked, where is everybody? That's very presumptuous, by the way. It's just like, sitting on the couch at home and saying, I don't hear any knock on the door, therefore I don't have neighbors. Like, we've been recording history for 10,000 years. We haven't seen anything during that, and even that is disputed. We haven't seen anything, therefore we don't have neighbors. Why would the neighbors come to visit us just in the last 10,000 years? That's 1/1,000,000th of the age of the Milky Way galaxy. And they could have come 1 million years ago, nobody would have noticed. They could have come 1 billion years ago and only the microbes would see them, So the point is, it's very presumptuous to say, oh, they don't have a party in our backyard, therefore they don't exist. And I think a much more appropriate approach would be to say, well, first of all, they may have visited many times over. And second of all, we're not using the best instruments right now to search for them. So that's why we are not seeing them, because, it might be small objects that you have to look very carefully to find. And, there is this concept in ancient Greek mythology that the ancient Greeks appreciated hospitality very much. They, in fact, even their god, Zeus, was given the attribute of respecting strangers. Okay, and it was called xenia. And you might think today hospitality, back then it was very useful for the ancient Greeks, because they learned about what happens far away by welcoming visitors. And my point is, you might think today, we have global trade, we have the internet. We don't need to appreciate hospitality as much. We can get the information. But that's true on Earth. We don't have any information in between stars. Interstellar cultures, are not known to us. And my point is, we should adopt interstellar xenia, meaning respecting the possibility that there might be guests coming from other stars, and we should welcome them because we can learn something new from them. And that would be rejuvenation of this concept of xenia that the ancient Greeks appreciated a lot. They were very clever.
You are an absolute breath of fresh air, Avi Loeb, I have to tell you. Let me get to a couple of these super chats real quick, and I'll let you get out of here. I know you're a very, very, very busy man. All right, so Aprop says with his donation, Lou Elizondo said inexpensive sensors could detect objects and only need one might be needed. To what do you think he's referring? What specific frequency on Galileo's sound sensor has most efficacy?
We don't know in advance, but I should say two things. One, with respect to infrared emission, any object moving in air encounters friction, and as a result gets warm. We know that from the space shuttle, and we know that from supersonic jet airplanes, they get warm. And I have an undergraduate student currently. She's constructing a model that would give us the expected infrared emission from objects of different sizes moving at different speeds. And of course, we will check for that. If we see an object moving in the sky in some pattern, we can monitor the infrared signature of this object and see if it's consistent with her models. So that's, and with respect to sound waves, in much the same way, there should be a sonic boom when an object moves faster than sound. We see that in meteors when they move through the air. We see that in supersonic jets. And so we will use that information to figure out the nature of the object. And for example, if the object moves really fast and doesn't warm up, that would be interesting because it means somehow there is something soaking the energy that is hitting the surface into the interior of the object. That would be an interesting revelation for us. So altogether, what I would say is looking at UAP with scientific eyes, with a scientific analysis, allows us to learn new things about the nature of the UAP. And we want as much data as possible. We want to keep our eyes as open as possible. I remember what my mother told me the day I was born, my birthday. She said, "Well, I saw you in the delivery, after the delivery in the room together with all the babies, and you looked very different to me because you kept your eyes open, looking around the room and wondering about the world, while the other babies were just focused on their immediate vicinity." That's what my mother said. I'm sure that she was biased. She was an unbiased observer. But I should say this is pretty much my goal in life as a scientist, to keep my eyes open and get as much data as possible.
Well, we appreciate that. Bottled Water says, so excited for the project, for the Galileo project. I'll be donating tomorrow. I pulled into a gas station. Michael, I'm not texting while driving. Thank you very much, Bottled Water. We want to ensure the safety on our roadways while folks listen to Avi Loeb here. I got two more, sorry. How can someone like me who is not smart push this conversation forward? And I know you are very smart, Kelly, so don't even say that. But how does somebody help in this conversation? How do we push this more to a scientific perspective if we are laymen?
Well, two ways. One is, of course, to follow the project and support it publicly. And the second is, whenever ridicule appears on social media, to approach those people that ridicule. For example, there was a review of my book, Extraterrestrial, in which the reviewer was saying, there is nothing really unusual about Oumuamua. That's what the reviewer said. And this reviewer claims to be an astrophysicist, even though he didn't publish for a decade. So my point is, this is not true, because there were teams of astronomers basically trying to explain the anomalies of Oumuamua. It was definitely unusual. And these teams had to come up with something that we've never seen before, like a hydrogen iceberg, nitrogen iceberg, a dust bunny. They would never go through the trouble of writing many scientific papers suggesting something we've never seen before if there was nothing new about this object. Yet this person says that. And why does he say that? Because he has moral support from a group of other scientists that just want to shut down this discussion. And at the same time, they are making personal attacks. They are basically dismissing things which are clear, like there is evidence, scientific evidence, that Oumuamua was unusual. And, this is an acidic culture that basically wants to remove any discussion on this subject. And my point is, I mean, the general public can counteract that. And when people say things that are incorrect on social media, they can say, well, if someone says, I don't like the book because Oumuamua was not special, just tell him, I actually like the book. And, I think it would make a difference if the level of the discussion was uplifted. The discussion would be more open-minded, and investigations like the Galileo Project would be welcomed. I just don't see how scientists can reject a project that is aimed at getting evidence based on funds that were not allocated to science before. That should be welcomed. Everyone should embrace it. People should be thrilled that someone is doing this work. And nevertheless, you see the scientific community negative about it.
Yeah, Case for Insanity said, yes, I just posted today. Ridicule is not part of the scientific method, J. Allen Hynek. Avi, is there anything that you would like to, maybe I didn't ask you, that you'd like to leave folks with? Anything that you think is important in regard to this discussion?
Yeah, I think the most important point is I'm trying to create an intellectual climate that would welcome young scientists, because they're not prejudiced, and I get a lot of them interested in the Galileo Project. They just worry about their job prospects. And when senior scientists ridicule this subject, they are worried that they might not get jobs. I mean, and we need to change that culture. So the goal of my work is pretty much to create a reality where this subject will be mainstream in science, where the young people will be able to work on it, because I think they will be extremely excited about it. Science is not supposed to be boring. It's not about, giving credit to old people, giving respect to old people that celebrate their accomplishments throughout life. It's more about understanding the world that we live in. And that's a very different objective. So we should not be trapped in notions of the past. And if you were to approach Marie Antoinette and inform her about the principles of the French Revolution, she would not embrace it, because she benefited from the old system, right? And so the scientists that ridicule the subject, that object to it, benefited from the old system, and they rejected any change. But I think the future is really with young people. And what I'm trying to promote is the interest of young people and change the culture such that they would be able to work on it freely. And we're making headways in this context. And I very much hope that in the coming decades we'll discover the answer to this question: are we the smartest kid on the block? Probably not.
Probably not. Avi, thank you. It was an absolute pleasure. Oh, I did have one last one for you. Some folks were talking about Elon Musk, and Elon Musk actually appears, and this may have been an ironic post or something, but it appears he has changed his tune on UFOs. Would he be somebody that we should try to be rallying to come knock on your door to help you, support you financially on the Galileo
That would
Project?
be wonderful, because, for example, SpaceX can help us with a mission to take a high-resolution image of an Oumuamua-like object that we discover with future surveys. So I would very much love to collaborate with SpaceX on this, and with Elon Musk. If he can, if he shows interest, I think the Galileo Project would be a fantastic match. Now, I should say that there are wealthy individuals that lifted their body by 1% of the Earth radius in recent weeks. And they felt very proud of themselves. One thing that we have to keep in mind is that showing off in space is an oxymoron. Space is vast. It's the observable universe is 10 to the power 19 times bigger than the radius of the Earth. So if you lift your body by 1% of the Earth radius, that's not a great accomplishment. But if you discover that you can travel across the entire galaxy, or that you find others that did that already, that would be something to be proud of.
Take that, William Shatner. Avi, what a pleasure it was to have you on today. We really appreciate your time with us. If folks want to read more and find out more about you and the Galileo Project, how might they do that?
Well, they can go to the Galileo Project website, which you can find by typing in Google Galileo Project, Harvard University, Avi Loeb, or they can come to my, they're welcome to see my website, professional website at Harvard, where they can find also my commentaries that I publish every few days on the subject that update the progress in the Galileo Project.
Fantastic. And below, I've put in the description, Avi is a prolific writer, so keep up with him. You can follow the links there to follow him on Medium, Scientific American, Harvard. It's all there. Avi, thank you so much for joining us today. We really appreciate your time.
Thanks for having me.
All right. Bye-bye.